Good morning, everyone. This is going to be on lesson Patterns in Algebra, grade 7, lesson 23. It's found on page 91. So, we have been discussing different ways to represent information and to discover rules and formulas. And here are two ways that we've talked about before that should be somewhat familiar to you. So I have my rule right here, which is 4 times I equals O, or 4 times input equals output. And then I made this t table right here, and then did the exact same formula, and I made this t table here. Okay, so inputs on one side, outputs on one side, on the other side, and it goes 1, 2, 3, 4, and then output 4, 8, 12, 16. And then my x is 1, my y is 4, and it's the exact same, just with different variables. Now, what we can do, and what we're trying to understand, is we want to have sort of a bigger formula, a formula that we can sort of go back to every single time. Whenever we have t-tables, we want to sort of be able to figure out the t-table with a baseline formula. Okay, so what we're going to be working on today is we're going to be switching the variables input, output, or x and y, to term number and term. So term is going to be like our output, term number is going to be our input. This is especially a good way of doing it when we work with numbers that have sequences. So here I've changed up this exact same formula. These are all three the exact same formulas. I've just changed the variables. So the first one I had input, output. Next one I have x and y. And this one I have term number and term. Now term numbers are easier to deal with if you think of it as it just starts at 1, 2, 3, 4 and just counts its way up. So that's term number. So I have them right here, 1, 2, 3, 4. And then I have the term, which is the output, 4, 8, 12, 16. And this exact same table is represented over here and over here. All right. Now, with this formula, or with the way that this is written out, I can think of my sequence fairly easily because it's all written down pretty much like this. So my sequence is actually right here. So I'm going to say, okay, this is my sequence, 4, 8, 12, 16. And then I can say, okay, well, my rule is I start at 4 and then I add 4 each time. Okay. Now that we sort of have that figured out, this is just another way of representing these other formulas that we've done before. Okay, so term number is my input, term is my output, then I have a number that's applying or changing the term number. Now let's look at a question that has an original starting point, right? So I have 3 plus 4 times Tn equals T. Now this first part of this, or the second part of this equation, is exactly what we've dealt with before. We're just adding the 3 plus. Now this changes up the sequence quite dramatically, where now we have starting at 7, 11, 15, 19, and we can say the sequence is 7, 11, 15, 19, and the rule is start at 7 and then add 4 each time. So what we're wanting to understand about this is when we have this first number being added, right up here, we want to think of this in bigger terms that we can have other formulas sort of fit into this. And what we're going to say is this 3, we're going to, in a general formula, we're going to say it's like A, okay? And then I'm going to say, okay, so this is A plus B times term number equals term. We're kind of like we're working backwards almost. Like if you imagine when we did, if we found the formula of perimeter, or sorry, let's say area. The class started off with me saying, okay, this is what the formula is for area. We're going to talk about this idea. What we've done now is this is the formula that we're working off when we're talking about area. This is the formula we're going to be working with when we're talking about graphing linear equations. Okay, so we've sort of done it backwards. Where usually I say, okay, this is the formula that we're going to use, and then we're going to put different numbers into L and W or A, and we're going to slowly figure out how this all works and get really comfortable with it. We've actually done it the reverse. So what we've been doing is we've been working with formulas that look smaller than that, or we can add in numbers in, and now we're saying, okay, as a general rule, this is my formula that I'm using for any linear equation. Okay, this is my linear equation formula, right? So now Now that we're sort of understanding or seeing that this is a linear equation, so a plus b times term number equals term, we're going to be asking questions and learning about how does this formula work exactly. These last couple of questions on page 91, 2 through 5, they're going to take you to do a little bit of thinking. All right. It's a little bit different than what we've done before, but what we're saying is this is our new equation. This is what we want to sort of imprint in our minds, that this is how we do things now whenever we're talking about linear equations. Okay, so I hope this is helpful. We're going to have another lesson right after this, so I will see you in the next one.